They are the brains of the modern world. But how do we build these microscopic marvels that power our lives? It all starts with sand. Through intense heat and complex chemistry, silica sand is purified into electronic-grade silicon. This pure silicon is melted. A seed crystal is slowly pulled upward, growing into a massive solid cylinder called an ingot. Using a precise diamond wire saw, the heavy ingot is sliced into ultra-thin discs, called wafers, and polished perfectly flat. Even a dust speck can ruin a chip. Fabrication happens inside ultra-clean rooms, bathed in yellow light to protect sensitive chemicals. The wafer needs a blueprint. It's coated with a light-sensitive liquid called photoresist, then spun at high speeds for an even layer. Next is lithography. Ultraviolet light passes through a stencil-like mask, projecting the complex circuit design directly onto the photoresist. Chemicals or plasma wash over the wafer. This etching process removes the exposed areas, carving physical, microscopic trenches into the silicon. Pure silicon doesn't conduct well. A particle accelerator shoots specific ions deep into the silicon lattice, fundamentally changing its electrical properties. One layer isn't enough. This expose, etch and dope cycle is repeated dozens of times, building a complex 3D microscopic city. Billions of transistors are now formed. Microscopic trenches are filled with copper, creating incredibly tiny highways so the components can communicate. After each new layer, the surface becomes uneven. A spinning pad and chemical slurry buff the wafer perfectly flat for the next step. Once built, a specialized machine uses thousands of microscopic pins to test every single chip on the wafer, marking any defects. Precision saw cutting the circular wafer into hundreds of small square chips. A high-speed, diamond-infused saw cuts along microscopic grid lines, separating the single wafer into hundreds of individual chips, known as dies. Functional chips are delicate. They are mounted onto a substrate, connected via microscopic wires, and encased in protective black plastic. Packaged chip pushed into a motherboard, zooming out rapidly to a modern, glowing city. After final stress tests, they are shipped worldwide, from a handful of sand to the tiny brains powering our modern civilization.